Hello.
Hello.
Hi.
So I guess we'll wait for a few more minutes and see if other
Hi,
people
hello
will
everyone.
join. Hey, good morning.
Hi.
Okay, so I guess I just start, if that's okay with everyone. Yeah, hello everyone. My name is Marco. I'm a software consultant at TNG, and I want to welcome you here today at the show and tell Magma VMs, our little session. If you have any question during this quite informal and not very polished style presentation, then just feel free to ask, and please interrupt me. And our goal is to be finished until within 60 minutes until the DevOps monthly, and I just want to advertise it. So this will be the meeting after our little session here. A short introduction to myself. My academic background is in physics. I obtained a PhD in physics, doing experimental work on superconducting quantum circuits. And after that, I joined TNG, and I'm part of the Magma team since April of last year. And my focus was, I don't know if it's mostly, but I did a lot of stuff in the S1AP LTE index tests in the containerized version and the non-containerized version. And also I did a lot of work on the HW VMs and providing a new base image. And I will tell you in a few minutes what this expression means. And so, yeah, welcome to today's session. And I will start by showing you a little bit the outline. So, yeah, what I want to talk about today is about the HW VMs, and I want to introduce them to you and give you a little of background knowledge what these VMs represent in terms of a translation to a production environment. And then I want to continue talking about how they are set up, either for development or in the CI jobs. A little bit about housekeeping, where are they stored actually, and what is needed to create new base images. I use this expression for the second time already. And then, and last, maybe give a little outlook, because there were there's some questions already last week about ARM-based Magma VMs. So what my goal is for you after this little session, I want you to have a basic understanding of how Magma VMs work. It would be quite surprising if you would know this by heart after this little session, but my goal is for you to have a starting point and where to look to find further or more detailed information if you have a specific question, and just have a starting point if you want to create a VM on your own, where you could start and find your way through the code. And I mentioned this already, a short disclaimer. So this talk, I will focus on the HW VMs, but especially from a tech stack point of view, the CWF and the FEG images are very similar. They just represent a different part of the Magma core in production environment. Okay, and if there are no first question, I would continue with the first block. So in Magma, we have 3 virtual machines which are needed to fully test the HEW. And all of the 3 VMs, they're used in CI and also used for development if we create pull requests or do some logic changes there. And the 3 VMs are the Magma Dev VM, so Dev for development. We have the test VM, and we have a so-called traffic server. And these represent 3 different parts you would need in a mobile network. And the Dev VM is basically the developer's version of an Ubuntu server where you would install the Magma Debian package. So if you want to set up your own Magma network, in our docs, it says take a Ubuntu server and install Magma. And this is basically what is done here. It's just a developer's version, which then adds a couple of features. We basically have a lot of development tools also installed. Of course, all the prerequisites for running or developing on Magma or with Magma are already installed in this VM. And a nice feature is that this VM, when you start it on your local machine, it basically links the Magma folder on your local computer to the Magma folder in the VM. So all the changes you do during development in your IDE, they are already then present in the development machine. And this is actually true for all the VMs I will talk about today, and probably not true for all Magma VMs, but for most of them. And in real life, this dev VM basically represents, as I said, the installed Magma core, the access gateway on your Ubuntu server, which you would install on premises. The second VM is the Magma test VM. And what this VM basically does during CI and during tests, this VM simulates the UEs, the user equipment, which are connected to your access gateway. And at the same time, it also doubles and executes the S1AP test framework, which means not only mimicking the user equipment, but also controlling the access gateway VM during the test execution. So, for example, if some Magma services need restarts or we have special wait times, this is all done on the test VM. And last but not least, the Magma traffic server. And this VM basically represents the internet. So if you think of a mobile network, you have your cell phone, it is connected to your provider, and then it goes further to the whole internet worldwide. And so this string of components is represented here with the test server as basically your mobile phone. The dev VM is the mobile network provider, and the traffic server, the internet, on the other side. And what basically the traffic server does is, as in running tests, is it provides a traffic server to test the up and to download data from user equipment via the access gateway to the internet. And now, while they are very different in role and very different in complexity, basically all these three VMs are created very, very similar. And for the purpose of this talk, and to reduce the complexity for you, I would like to continue to talk only about the traffic server, because the others are quite not complicated, but very complex in their setup, and it doesn't add anything for the basic understanding. Okay. So how are any questions so far? I'm sorry. If there are, just throw them in. And
I have a question. We have these three VMs, but if we have to set up them from scratch, I know that there are packages pre-installed in these VMs. These are actually VirtualBox VMs. But how do we create this VM from scratch?
I will come to that. This will be coming to, basically we're going backwards. Yeah. So I will talk about how we are going to set up. And after that, I will talk about how they are made from scratch. And as I just said, the process is very similar, especially the tech stack that is needed is very much the same for all these three. So I will explain the whole process for this traffic server. And as Shubham just mentioned, basically they are at the moment VirtualBox machines. So there were some virtual machines provided via libvirt or like QEMU, but they were not supported probably for some years now, and never really maintained. And while these are VirtualBox machines, in your everyday life as a developer, you will mostly come in contact with a tool called Vagrant, which is provided by the HashiCorp Corporation, which will be mentioned in this talk, well, probably quite often because we rely quite heavily on their tools.
I have a question about the hardware you use to run this.
Yes.
Running a virtual machine on a Intel chip is probably going to lean towards older systems. Like my own Intel Ubuntu system is pretty old. Are you able to run this on an ordinary laptop, or do you have some kind of super beefy?
I do have a Dell laptop sitting next to me. I mean, it's not the most basic configuration probably, but we at TNG, we work with like ordinary laptops, which are probably in the higher price range, but nothing out of, nothing too expensive, I would say.
Okay, thanks for that.
Yeah, so
and
VMs actually works on an x86 systems. We tried libvirt previously, but on Mac OS libvirt doesn't work correctly. That's why we stick with VirtualBox. That's
yes.
Yeah.
Exactly. And with Macs and their ARM chips, it's even more complicated. I think VirtualBox now does support the M1 or M2 MacBooks, but I can't comment on the performance. I have no idea what or how this is really in real life. As I said, everyday life, you're dealing with Vagrant, and similar to Make and their Make file, Vagrant has a so-called Vagrant file, which we'll take a look at in a second. And the basic command you will also find in the docs. It says here, it says Vagrant up Magma traffic server, and then we SSH onto the machine. So the whole communication is done via this tool. And it's also like, quite easy to use then, because you just have to tell it, okay, I want to use this machine. If I want to use a different machine, I would just type Vagrant up Magma test, for example. And what this command does and what this Vagrant file in the end does, we start with a VirtualBox image. We add some special settings, for example, the username or so, and some virtual hardware requirements. And then we take this, this VM box and customize it via another tool called Ansible. And I want to show this now to you in the code a little bit. So this is the Vagrant file. It's located in the LTE gateway folder. And somewhere here you can read Magma traffic server. And so this is basically, this part defines the infrastructure for the traffic server. So what is happening here? We say, okay, we want to start with a box, and the box is stored somewhere. We will come to that later. The box is called Magma traffic server. So by the name, you can tell this is already something that we provided as developers. This will come in the next step. After that, we say, okay, we want the specific version of this box. We give it some network settings, and then we say, okay, we use VirtualBox as our provider and have some memory and CPU settings to the virtual machine. We can skip this part because this would only correspond to the libvirt as a provider. And what we in the end then do, we take this box with this specific settings and say, okay, we want to provision this box, which means we want to change it by using Ansible. Ansible is basically does infrastructure as a code. And we say, okay, this Ansible playbook, they call it playbook, their recipe to fully change the VM. the playbook is located here. It's a YAML file called Magma Traffic Server. And if we take a look at this, this looks quite simple. And this is basically very readable. So the overall headline is we want to set up an iPerf traffic server machine. We have a host file. So that's this host file where the network settings are also, again, stated. So we take the traffic server entry from this host file, give it sudo permissions, add some local variables, and then we execute this role here. Again, I will show you this in a minute. What's very important here are these variables. The first one is quite simple. It's the Magma root directory, which will be located in the home folder of our user. And the second and third variable, pre-burn and full provision, this is something Magma specific, but this will appear throughout the whole provisioning process. As I said, we start with an already defined box, a box which was defined by Magma developers. And then on this defined box, we execute several steps with Ansible every time you do the vagrant up command. And these two steps basically are called pre-burn and full provision. So for everyday life, you see here the settings. Pre-burn is false because we already get the predefined image and only execute the steps that are marked with full provision. And you will see once we take a look into this role that most steps that take a lot of time or a lot of internet data are already done in this first pre-burn stage. And once you as a developer just want to vagrant up a machine, only the full provision or the steps which are marked with full provision are then executed. And these are usually the cheap steps which don't cost a lot of time or resources. Okay, let us take a look. If there are no more questions, let us take a look at this role here. I already opened this already. And this is basically, these are steps in the syntax that the Ansible provisioning system uses. And I just want to go through it so that you get a little bit of understanding of the code and the syntax. So first step, it has a name. We want to create symlinks for scripts. And we use this file module. We have a source and a destination path. We want to link source and destination. And we want to do this in the full provision step because this doesn't cost much. And if we change something, we don't want to have to build a new base image. Similar is true for setting the host name. We use this built-in module to set the host name. Down here, most of the steps you can see are only executed when pre-burn is true, which means not at all if you start this VM on your local machine. And these are then, you can see, for example, here, apt install packages installed with apt. So you call the apt module, name the packages you want to change, and then you have a state indicator. And here, in this case, we want to have these packages present after we execute this step. And similar, it's true for some pip packages here, even more apt packages. And what Ansible does basically is go through these steps one by one in a linear way. Nothing is parallelized. Nothing gets optimized for anything. So we just want these steps to be executed one after another, to have then a VM which is in a specific state that we wanted. And when I scroll down, you can see the pre-burn variable highlighted. So most of these steps here are basically executed not on your computer, but were executed some time ago by developers who built this machine. This has, again, the advantage that the startup time on your local computer or in CI is very fast compared to a case when you would have to download and install all these packages and make these adaptations. Any questions to this or comments? Okay, great. Why did I choose the traffic server? I mean, you could see here, this is only one role here, which is not that long. The other two VMs I talked about have multiple roles. Some of the roles import other roles, so it's just a little bit messier, but in the end, it's all the very same syntax. It's just a little bit more complex. Okay. Now, when we start with these images, they have to be stored somewhere. And indeed they are. They are stored in the Vagrant cloud. And we have an account there, a Magma Core account. And we this can be managed with a CLI tool. And the access credentials are managed by the Linux Foundation. And I want to show you a little bit, or I want to show you where this is. So if I Google Vagrant Cloud and Magma Core, you can see I clicked this link already at some point. This is our account, our site, so to say, at the Vagrant Cloud. And you can see all the VMs, all the boxes that are associated with this account. And if you take a look here at the download numbers, it's probably quite clear that these three VMs I mentioned in the beginning are the ones with that are the most prominent. And if I click here in the traffic server, so the latest release was at the beginning of the year, and we have a provider for VirtualBox. And if we scroll down, at some point there were some boxes provided with libvirt, but yeah, this support, or this was not supported by the community anymore. So basically, this is the place where you get these images, and the version number is the one which corresponds to the Vagrant file in the beginning. Okay, any questions so far? Then the big question Shubham already asked in the beginning, how do we create actually these space images? Because this is probably also the most interesting point for developers to go in the future. And we use a tool which is called Packer. Again, Packer also a tool from the HashiCorp Corporation. And what this tool does, it takes a config file with your inputs, and that out of it creates a virtual machine. In our case, a VirtualBox virtual machine. And from the basic setup, it starts with an ISO file from, in our case, an Ubuntu ISO file. It also takes some user settings and some settings for the machine. Then it basically installs this OS on a blank box automatically, which means we have to provide Packer with a boot command, which basically are the keystrokes, the keyboard inputs you would have to do on your keyboard if you want to install this specific operating system. And so there are quite a few lines, I will show you in a second, quite a few lines of, well, strange keyboard strokes that are needed to install Ubuntu 2024. And after we installed the base operating system, we apply some scripts. For example, we want to use Ansible to do the pre-burn provisioning, to execute the pre-burn steps that correspond to the VMs. And this means we have to install Ansible, for example. And this is only one of some steps that are executed before. And then we go through all Ansible roles that correspond to the virtual machine we want to build. And this time, the setting is set to pre-burn true and full provision false, which means we only execute the steps in the Ansible roles I showed you a minute ago that are marked with pre-burn. After that, we clean up the machine, which means we want to make it as small as possible so that the download is faster for developer. And this usually means to uninstall all packages that are not needed, and to maybe also do some tricks with the hard drive space. And then in the end, it gets packed into a box, which can be handled either by VirtualBox, by Vagrant on your local system, or you upload it to the Vagrant cloud. And so there's an upload script for it in the Magma repo. The box gets a timestamp from the current date. And if you want to do a PR, if you want to release a new an image and you did all the testing, of course you have to change the versions in the Vagrant files and in some points for the CI where we do some caching of the boxes. And there's also a little script for CI that we wrote some weeks ago as a draft, which would basically do this step of packing and uploading the VM by itself as a CI job. Okay, and now I want to show you what I just talked about to give you a better feeling. This is the Packer script. It's located in Orchestrator Tools Packer. You can see the file system on the left-hand side. And we're here in the JSON file Magma Traffic Server VirtualBox. We start here with the ISO URL of the operating system we want to install. In our case, the Ubuntu Focal image. And then we have to set some settings. That's a VirtualBox ISO. We run Ubuntu 64. We name the VM. We set some SSH credentials. And this, for example, is the boot command, which is needed to install Ubuntu on your on a blank computer. And it's quite impressive. If you build this machine, you can open VirtualBox and basically take a look at the system typing in these commands automatically. It's like you're watching a video. After that, we set some memories. And then we are in the provisioning steps. These are the scripts I talked about, which are needed for the prerequisites. In this case, this means doing some installation of, for example, Ansible, and changing some vagrant-specific settings. After that, for example, we do here a reboot. We update Ubuntu. We here use a third-party script from a GitHub repo, which I will also come back to later. So this basically, the script ensures that the Ubuntu we are building here is at the latest version. And after we did all this, we come here to the Ansible playbook that I showed you in the beginning. So we basically provide this Ansible playbook here to the config, and we provide also the path for all the roles that are needed, and we set here the pre-burn variable to true and full provision to false. And after that, as I explained, we have some cleanup steps. Also here, some third-party, some scripts from third-party repos, which we found quite handy and helped us to minimize the box sizes when we first applied them. I think probably by a gigabyte or so, maybe half gigabyte. And afterwards, it spits out a file with the VirtualBox ending.
Sorry, Marco. One question from the chat from Lucas. I don't know, Lucas, if your question is already answered. It is about the cleanup scripts. If you can go into more detail there. What is happening?
Sure. Yeah.
Thank you.
Let me. Sure. Yeah. Sorry, I don't see the chat here in the screen share. Okay. So the scripts are located in the script folder. It's this cleanup script, for example. So what we do here, we remove Ansible, we remove the Ansible PPA that was added in the beginning, and then we do an auto remove and an auto clean from all apt packages to clean up apt, and we remove some files we don't need. So this is the easy part. And for the third-party steps, I think that's another cleanup. This is more really going into the minimizing process. So we remove some Linux kernels we don't need, some docs packages, we purge libraries. As you can see here, remove several folders of not needed firmware. Basically throws out a lot of stuff that is not needed for our requirements, but is still present in when you would install Ubuntu. Does this answer your question, Lucas?
Okay. Yes, this is exactly what I need, and it's super interesting and relevant.
As I said, these scripts were not written by us, so we already we found them, and as a matter of fact, we adapted them. So when I did this the first time, there were still some bugs in the system because this cleanup script removed the bash completion. But this is still very handy for development when you navigate the virtual machine. So we decided to not purge it here in this step, but leave it on the machine. So this script is more about cleanup. Minimizing is now another step deeper, again, third-party script not written by us, where basically there's a lot of zeros written in some parts of the partition and whatnot. So this really helped us to bring down the box sizes. And if we take a look here, for example, in the development VM, so we started here with 3.2 gigabyte and ended up with roughly 1.7. So we purged 1.5 gigabyte of size, which is then less data you have to download and a speed up in the whole process. Any more questions about the process that I just talked about?
I have a question regarding Packer. Why are we using ISO image instead of Cloud Init image?
That's a good question. So you maybe notice that we're using the legacy ISO system, so to say. We tried to change this. I think it was in autumn when we did a release, but had a lot of trouble with Packer performance and box sizes. So when we tried to change this, we had a lot of packing runs that just failed, that took very long, and afterwards the build images were very, very huge and very, very slow. Our fix, our midterm fix then was to still use the legacy ISO. And you may notice here we use the 2004.1 ISO image because that was the last Ubuntu version which was released as an ISO file. And this is why we here have this update script, which then pulls the Ubuntu image up to the latest 2004.5.
And what about the kernel restriction that we have, that for the OVS, we only need 5.4 kernel? This image have that exact kernel version, right?
We made sure that the needed kernel versions were not deleted afterwards. But as you say, it's very important. We have some restrictions on the Linux kernel. And this is why testing, of course, a new base image is very important to make sure we fulfill all the requirements from or for our Magma packages.
And this process is handled by our CI system, or some developer have to do it manually and push it to the Vagrant Cloud?
Yeah, at the moment, this is done manually. Manually in a sense that I prepared a shell. So this is the manual process. It says Packer build, and then I do give the traffic server JSON. And if all runs well, I end up with a box. And usually the changes are not that much in this Packer file, but what you would change is something in the provisioning steps here, which means the packing process itself is usually not that critical. It becomes critical once you change operating system versions. But as soon as you end up with a packed VM, of course, then begins a lot of testing. You basically have to test every feature of Magma, every test that is made in CI, every unit test, every integration test you have to do on your computer with the newly built box.
And how much time does it take to build the entire box?
With the packing process, takes on my machine, depending on which VM I built, between 20 and 45 minutes. Of course, this depends on your local machine, but on my laptop, it takes, let's say, 45 minutes. And then testing takes as long as testing takes. That's a little bit, something we can't really predict.
What would be testing? I mean, what would be the steps to test after you build this image?
I can show you maybe the latest PR I did when we upgraded the versions. So this was not long ago. This was just merged last week. Sorry. So this was the PR. So what we did, and keep in mind, these were just the HEW images. So we did all HEW unit tests, all pseudo tests. We compiled the HEW. We compiled it in a container based on Docker. We did the LT integration tests with the systemd version, the integration test with the containerized HEW version. We basically built NMS. So we built an orchestrator locally, connected it to the HEW, and then we built NMS to get to the board. We executed the federated integration test suite and the CWF integration test suite, which also includes some unit tests, but they are executed on different machine. We did this once locally, then uploaded the box to the cloud, and then redid basically all of these tests in CI with the GitHub Action Runners.
Thanks.
Okay, and just for completion, or to complete this is the upload script. What happens here, it sets the version to the current date. You provide the cloud token, which is handled, as I said, by the Linux Foundation, and then the Vagrant CLI takes care of uploading and releasing with the rest.
A small nitpick, line 10.
Yes, please.
Does it need to be changed to 1.3?
Yeah. I will. Okay, let's open the PR afterwards. Thank you very much. Yeah. Okay. And are there any more questions to the whole packing process? If not, I have like a small outlook, because I know there was interested in ARM-based packages or ARM-based VMs. This is basically, with ARM, it gets a little bit complicated, because all our CI, which runs in GitHub, this only runs on x86 machines. So one would have to, as soon as we would have these functioning VMs, we would need a second CI, maybe run it on AWS, for which we have no account or no funding at the moment. And if you want to switch, then the whole CI, you may think of adapting all the 3 VMs. It may not be suffice to only migrate the development VM, which is the HEW VM, but also the test and the traffic server as well. I heard about strategies that we may want to use Docker to build the test framework or the traffic server framework, similar to what we now already do with the HEW. And as another point, basically, At the moment, we don't produce any ARM artifacts. We don't build or we don't upload any ARM artifacts to the repository in CI. So this is also something you would need to think about. Nevertheless, if you want to attack this challenge, basically as a starting point, besides what I just talked to you in the last some minutes, there's a Magma Wiki entry, which we try to keep up to date. This is a short compressed version of what I just told you. From starting step 0, if you plan to upgrade to a new distribution, to the whole testing, publishing, and what a PR that changes the Magma repo to a new virtual machine version needs to contain. You are very welcome to read this, to comment on this, give some feedback. And this should be a start to start for you to start working with ARM images. I can also recommend this repo from the Chef Bento repo. We have, or this is one of the repos we have these third-party cleanup scripts from, and also the boot command, I think, was heavily inspired by their work. And they are actually, they provide some templates on how to build various Linux machines, and I think only Linux, I'm not quite sure, with Packer. And towards the end, I want to show you, as a little teaser, a CI job we created. So this is a draft PR marked as work in progress, as a kind of CI job to set up Packer. You have to provide, of course, the access token yourself. This is not saved anywhere in the repo, and then it would pack the machine and upload it to the Vagrant cloud. I would leave this for the community to decide what to do with this information. If the community wants to stay in a manual process, or if we want to try to at some point maybe more automate this whole approach. Are there any more questions or comments at this point?
Marco, your talk notes here might be useful documentation for the future.
Mm-hmm. Yes, as I said, pretty much everything or most of the things I said probably are already implemented here in this document. I can go over them and see if there are any more information that are missing here. But this should be very complete actually at the moment.
Yeah, Marco, going back to the ARM images, I mean, a quick win for the ARM images, and especially for the development. The S1 AP tester image at the moment is not something which is urgent, and I would argue that the traffic server is trivial because it just installs Cyperf. So yeah, you can do it even with a Docker, or you can do it with anything else. So the development image, what would be the effort and what would be the complexity to add a provider instead of VirtualBox to use Parallels, by example? Because VirtualBox is still not stable on ARM.
Yes,
so
yes. VirtualBox,
this is still developer preview. It's still developer preview, and as developer preview, it has lots of issues and lots of problems.
Yes.
But the stable virtualization environment, it's Parallels. So, and Parallels, I know that Parallels, Vagrant supports providers for Parallels.
Exactly. So you would basically, you would have to adapt this part here, because everything else should be the same. I don't think, I mean, these are just batch strings, yeah? So you would have to find out what you would need for, what settings you would need for parallels. You would, of course, have to start with not the AMD 64 ISO, but another image. You would have to adapt the boot commands, but this part here, the first part in this script, that's basically crucial to your operating system, or that's the operating system specific part.
Okay, understood. And then most probably we need to update the Vagrant file in order to register the provider as well.
Sure, you would need to add another provider, or no, probably not. That's true. You could have provider parallels here, and add whatever needs to be added here. I have no experience in it. So these are the provider specific settings in the Vagrant file for the machine.
Yeah. So
I see Shubham has a question. Yes.
Yeah. So if we are specifically talking about ARM development, because I was previously working with the ARM team for the access gateway, we have mostly tested it on parallels. That is one. And another thing we tested is on multipass. And it's much convenient to use multipass when building packages or deploying these images. So we can also use that.
Yeah, thank you very much. Are there more questions? If not, you know probably how to reach me. I'm active on Slack and on GitHub. So we have 5 minutes left until we have to switch to the next talk of today, so to say. And I would like to ask you for some feedback. Was this helpful for you? And you may know from last week's session that we are currently trying to establish these sessions to provide some knowledge to the community. So we were already discussing maybe future topics that are relevant to you guys.
I mean, it's fantastic information. Although we have things written in the documents, but it's much easier when somebody goes into the code itself and explains how the things are working. So it's you know, the uptake is much faster. And I would encourage all of us to ask for, you know, more show and tell things like this. Maybe now going into something very specific. This was, of course, this was very wide subject, and we were not able to dig into very specific things. Although we saw some very specific things like the cleanup of the machines, or the Ansible scripts, how the scripts are organized. So thank you very much for the show and tell.
You're very, very welcome. Yeah. So just as a spoiler, we were discussing today about maybe future topics, and given that there's now a push at the TSC by you, Jordan, about Bazel maybe dropping make support. So this was one of our ideas to have the next show and tell session about Bazel and the Bazel switchover. What we also thought about doing a show and tell was the release process, how to release a Magma version and what's connected with it. So if you would have some feedback for us, this would be great. So we could provide the information that are relevant to you.
I mean, it would be fantastic support to the proposal which I've opened today to have a show and tell for Make and Bazel, for everybody who is interested into this, to see what will be the changes. And for people, even later when we will have the recording, for people who will come later and then they will not find one or the other, whichever we will remove, just to know what was there and what was the way of thinking when we were removing one or the other. I'm not going to, you know, now say which one, but yeah. So this will be very helpful. And the release process, I would keep it as a separate. Yeah, sorry.
Sure. Yeah.
No, go ahead.
Lucas.
I was going to say that. Sorry, Lucas, go ahead.
I thought Lucas was okay. But
yeah, that was not me.
Oh,
okay, yes. Yeah, so sorry then.
Yeah. So my point was that this is, first of all, it's fantastic. Yes, and would love to welcome more show-and-tell topics. We had maybe we can just suggest on one of the Slack channels to TSC idea of the topics and see if that will encourage other people to sort of go and pitch in also. For example, I had I'm talking to the Canonical guys. They have done a Snap package for Snap install some of the components. I think that'll be an interesting one to do, put it in the queue someplace, things like that.
Yeah, we are very happy for feedback here, and see if we can provide with any knowledge to the community, or open this up to other presenters, of course.
I think it's just in a talk on the C++ migration. Where should we?
I can only shortly comment that we weren't really involved in this, so our knowledge may be limited, but maybe we will find someone. Yeah.
Shuji, or
yes.
I don't know, can maybe summarize that or give feedback there.
Yeah.
I can give some feedback on the C2C++. Apparently, this was an effort that was funded by Meta in the past with an outside vendor. But I don't think, looking at the progress, there's been a lot of progress in there that's substantial. It's been, the code base wasn't changed, maybe the compiler wasn't changed. So this is an open issue. I don't know where it stacks up, but probably we can track it as part of the components that we need to do.
Yeah. I mean, there are not much changes in the code itself, in the code structure or code architecture. What changed was, the code is converted from C to C++ to be able to be compiled as C++. But the code style and the architecture of the code is still very C-like.
Right.
Yeah.
Okay, gentlemen, I'm afraid we have to stop here and switch to the DevOps meeting. I very much enjoyed this. Thank you very much for the feedback, and we are waiting for any feedback on the next topics we want to present. Thank you.
Thanks.
Thanks everyone. Bye.
Thanks, everyone.